Hi guys, so in this tutorial we're gonna talk about how to delete node from a given position of singly linked list. So let's get started. Now as you can see we have already created one singly linked list with some dummy data nodes and we're gonna perform delete operation on this list. So let's say if we want to delete a node from fourth location which has data value 40. So for that we have to traverse each node of this list until we'll not reach to the previous node of given location node. So given location node we have 40 and the previous node of given location node we have 30. So from here itself we're gonna delete this node, and after deletion of this node, so previous node reference will start pointing to next node of given location node which has data value 50. So this is a small graphical representation discussion. Now let's get started with backend code. For that we have already created one class with name delete node from location, and inside this class we're gonna write one method which will be taking care of deleting node from given location, and also we're gonna handle some another use cases while writing the logic for this program. So let's get started. Private void, a method name will be delete, which will be expecting input parameter of integer type, where we'll be passing a location or a position of node which we want to delete, and let's create node of head of node type. Okay, so inside this we're gonna check whether head is null or not. Okay, so if head is null, right, there is no any nodes available. In that case we're gonna print message linked list is empty. Okay, and if there are nodes available, right, and head will be pointing to the first node of singly linked list, in that case we're gonna create two pointers as we discussed, which will be node type, right? The pointer name will be current, another pointer will be previous. Current is equal to previous, and initially both pointer will be pointing to wherever head is pointing. Okay, now we will be checking whether we will be using one while loop inside that. So exit condition of this while loop will be when current will be null, right? And we're gonna use one counter, right, which will be counting how many nodes we have traversed. So let's declare that count location. Initially count location value will be 0, right? And we're gonna check whether count location, if it is not equal to location, right, then we're gonna increase, we're gonna assign current pointer to previous. Okay, current, and after assignment of current to previous we're gonna increase current pointer one step, means we're gonna move our current pointer one step forward. Okay, so when we exit from this loop, at that time our previous pointer will be pointing to the previous node of given location node. I'll explain what I'm saying here, what we are doing here. So previous dot set next will be, so here in this point we will be using current dot get next, right? Now I'm gonna explain this this part what we have done here, right? So let's create some kind of dummy node. So that node has, sorry, dummy linked list. That dummy linked list has nodes as 10, 20, 30, 40, 50, and 50 reference will be pointing to null. Okay, now as we discussed, we're gonna use current pointer and previous pointer, right? So both will be pointing to wherever head is pointing. So initially previous will pointing to head, first node of this list, current will pointing to the same, and another we are using location, right? And the fourth variable we have count location. So this count location, count, right? Count location, initially value we have 0, and another one we have location. Okay, and let's say if you want to delete node from fourth location which has data value 40, right? So we're gonna pass location value as 4. Okay, now let's traverse this. So we have this list, right? This condition is true, right? It will come inside this loop, and we will be creating these two pointer, right? As we have created here, previous and current. Let's give pre current. Okay, so initially both will be pointing to wherever head is pointing. So head is pointing to first node of this list, right? Now we're gonna check whether current is null or not. So current is pointing to head node, right? So current is not null. This condition is true. Now another condition is count plus plus. So we are using pre-increment, right? So before comparison it will increment, right? So it will become 1. Then it will be checking whether this 1 is not equal to location, right? It is not equal to location because 1 is not equal to 4. That's true. It will come inside this loop, and it previous point, I mean we will be assigning current to previous, means current is pointing to this node and previous will start pointing to the same node, right? And in next statement we will be moving current pointer one step forward, as we are using get next only. So current will be moving one step forward, and it will start pointing to this node which has data value 20, right? Now again we're gonna check whether this while condition is true or not. Now current is pointing to this node, and we are checking if it is null or not. So it's not null. This condition is true. Now another condition needs to be true to execute this part, right? So count value, initially we had 1. Now pre-increment, after pre-increment it will become 2, right? Now we are checking whether it's not equal to location. So location value we have 4, means 2 is not equal to 4. Again this condition is also true. So both condition is true, as we are using AND operator in between of these two conditions. So this will become true, whole condition is true, and it will come inside this while loop. Now we are again assigning current to the previous, means this wherever current is pointing, so previous will start pointing to that node here, right? Now this line is executed successfully, right? This line is executed successfully. Now pointer will come to this line, and this line will be moving current pointer one step forward. Okay, now current pointer is here. We have moved current pointer one step forward. Okay, now we will be checking whether current is null or not. So current is pointing, which has data value 30. It's not null, and we're gonna check another condition of this AND operator. So again pre-increment, right? So the count location value gonna increase to 3, and we are checking whether this is null or not. So it's not null because, sorry, we're gonna check whether these both are equal or not equal. So right now count location value is 3, and location value is 4. So these both are not equal, condition become true again, and the first statement of while loop gonna execute. So we will be assigning wherever current is pointing. So previous will start pointing to that node right here. Now this is done. Now when pointer reach to this line, so this line will be taking care of moving current pointer one step forward. So let's execute this line as well. Now we are moving one step forward, right? So again we are checking whether current is null or not. So current is not null, right? Current is pointing to which has data value 40. This is not null. Now it comes to this another condition, right? So again pre-increment happen and count location value become 4, right? Now 4 is not equal to location, so count location value we have 4 and location value we have 4, so these both are true, but as we are asking for a not equal, so this condition become false, right? So as we are using AND operator in between of both conditions, so both conditions should be true, then only this entire condition of while loop will be true. But as this first condition is false, right, so this entire condition become false. Now as we discussed that when control exit from while loop, at that point previous this pointer will be pointing to the previous node of given location node. So given location we have 4, right? So 1 2 3 4 means this is the previous node of given location node, right? This is a given location node. Now from here itself we're gonna delete this node, and the reference of this previous node will start pointing to next node of given location node. So given location node we have this, and next node of given location node we have which has data value 50, right? That's why after exit from this loop we have we are using this previous dot set next, because previous is pointing to here. As we discussed that from here itself we're gonna delete this, and this will previous reference will start pointing to next node of given location node. So this is what we have done here. Previous dot set next means previous reference you should start pointing to current dot get next, right? Now this is what we have done here. I hope you got some idea here what we are trying to achieve, right? Now one another thing is, if this location value is greater than our list value, right? List count. Let's say we have list count here 1 2 3 4 5. So we have 5 nodes. So these nodes count we have 5, but someone is trying to pass here let's say 10, right? In that case we have to tell them that this is a wrong location, right? So let's do that as well. So inside this we're gonna check that if so location is less than or equal to 1. Okay, if it is not, we're gonna use else here. This is the one another condition I forgot to explain you that as well. So if someone is passing location in minus, right? Let's say if someone is passing location as -1 -2, or if it is 1 only, so at that point we have to delete one location, because that we have to delete node from first location, because that first location is only node which is a first node of synced linked list as well as last node of that list, but we have to perform the operation on it, right? So what we are trying to do, we gonna just assign head is equal to head dot get next. We are just reinitializing the head. Basically head will start pointing to the second node. Let's say if someone is trying to delete this, right? So head dot next is pointing to this node. So what we are doing, we are reinitializing head that you should start with this node. You have to ignore this node. This is what we are doing here. Okay. Now this is the first use case, and the second use case is when there are location value is greater than the nodes count, as we discussed 1 2 3 4 5, but someone is passing this location as 10, right? So what we have drivers are this list, right? This list, and this condition is always true, and the location, I mean at the end we reach here, right? Now current value become null. This condition is even true, but this condition is false, so this whole condition will become false when we exit from this loop. So if we are executing this line, right? So this line will be might be the wrong line, right? So before executing this line, we have to check whether this count value is basically greater than the location or not. Let's perform this operation now. So count location, if it is greater than location, right, then only we have to execute this line, else we gonna else if this location value is greater than the count value, right, then we will be simply saying wrong location, right? Because this location value should not be greater than the number of nodes count, right? As we have 5 nodes, so your location value should not be greater than 5. If it is greater than 5, then we're gonna print this message, wrong location, right? So these are the 3 use cases which we need to handle. Now let's write main method. Now let's create the object of delete node from location list new delete node of location, right? So using this reference, we're gonna access these non-static variable head as well as this delete method. So list dot, okay, we have to create nodes here first. So node first is equal to new node. Let's pass 10 here. Okay, copy 5 node. Second, third, fourth, fifth, right? Let's update these values as well, 30, 40, 50, right? Now let's before connecting, let's print display message, right? So print linked list dot display method, which is expecting input as head of node type. So this line will be printing all the list of all the nodes of linked list. So let's run now. There is no any node available, so we should be getting a message as null, right? Because there is no any nodes available. If it is non-null, okay, we are not passing, we are not calling this method. So let's call this method now, list dot delete, and we're gonna pass let's say 1 here, right? So there is no any node available in linked list. There is no any nodes, so this head is null, right? So it should not come inside. This should I mean this if block should not be executed, and it should come inside this else block and need to print this message, right? So let's run now. Now as you can see, we have this message linked list is empty because there is no any chain. We have not connected them together. Now let's frame a chain of list. Head is equal to first right, and first dot set next should be second. Second dot set next should be third. Third dot set next should be fourth. Fourth dot set next should be fifth, and fifth is the last node, and fifth next will be pointing to null by default, right? Let's print this. We are doing this already. Let's print this again after this operation. So let's print, let's not delete this for now. Okay, let's do it. So we should be getting message after deleting the node from first location. The output should be something like this, right? Let's execute this. Okay, so we are getting 50 only. So that is just because of we are doing some mistake in between, right? Okay, so we are moving current. What we are doing here is previous dot set next should be current dot get next. So current and get next. Display list dot head. When we are passing this, okay, first dot, oh, this should be first. See, because of this we were getting only 50. Let's rerun this. Now you can see we have this list created 10, 20, 30, 40, 50, and after deleting node from first location, 10 got deleted, and the first node become this second node become first node of single linked list, and the remaining nodes will be as it is. Now let's delete node from fourth location, right, as we discussed. So fourth location 10, this should no longer available after operation of this delete list, right? Okay, let's do it now. Now you can see this is the final output. You can compare this with this output, right? You can see 10, 20, 30 and 40. 40 is no longer available, and 50 we have because 40 was in the fourth location, which we asked to this program to delete, and that is working fine. Let's pass one another value. We are passing -4, right? So -4 value is not exist here, but we have one check here. If your location is less than 1 or 1, then you're gonna delete a first node of single linked list. So let's run now, and after run 10 will no longer available. See, 10 got deleted here, right? And the new list started with first node as 20 because there is no any location available with -4. So we are considering to delete first node only. Let's say if you're passing 10, okay, and there are only 5 nodes available. In that case, we're gonna print that wrong location, right? See, wrong location. So this is the before performing delete operation, and this list is after performing a delete operation. There is nothing changed, right? Just that the location where we are trying to delete the node is a wrong location. So we have done with this video, guys, and thank you so much for watching this video. Thank you.